So when we're told to simplify a radical, what this means is we're going to factor out any perfect squares, cubes, fourths, etc., depending on if we're talking about a square root or a cube root. So if we have, for dealing with a square root, any perfect squares, we want to pull out of the radical. So let's look at an example with just numbers first. So let's say we have the square root of 18. Now, I know we could put that in our calculator and we'd get something like 4 point something, because it's more than the square root of 16. But when we say we want to simplify a radical, which as we go on to higher math, we do this pretty often. So if we want to simplify a radical, we want to leave it exact, but pulling out any perfect squares in this case. So when I say I want to pull out any perfect squares, let's make a little list real quick of perfect squares. So I'm going to list numbers 1, 2, 3, 4, 5, 6, 7. We'll see if we can add to that if we come across bigger numbers. So 1 squared is 1, 2 squared is 4, 3 squared, 9, 16, 25, 36, 49, and so forth. So these are our perfect squares. So if any of those numbers, 1, 4, 9, 16, 25, 36, 49, if those are a factor of 18, I want to pull that out. Now, and actually, let's just skip 1, because we can always make 1 a factor. But looking at these other numbers, okay, I'm going to break this down. 18 breaks down to 9 times 2. So I would skip 4. 4 doesn't go into 18, but 9 goes into 18. So now using the product rule, we know that this breaks down to square root of 9 times square root of 2. I can do the square root of 9, that is 3. I cannot do the square root of 2 and have it be a nice number, so that just comes down. So this would be my answer of square root of 18 being simplified. So this would be considered my exact simplified radical, because I pulled out any perfect square that was in there, which was 9 in this case. And then anything that can't be simplified, I can't do the square root of, that stays in the radical, in this case in the square root. Okay, so how about the next one? Let's do square root of 75. Okay, so again, I'm looking at only the numbers that are perfect squares. So in this case, 25, square root of 75, I can replace that with square root of 25 times 3. 25 times 3 is 75. Okay, now a lot of times I might not write out this third step I did in the last example, but just think, okay, square root of 25, this comes out as a 5, but the 3 has to stay there. So it's going to be 5 square root 3. Okay. Okay, how about this one? How about 5 square root 32? So this I want to simplify. So this one's a little different. I already have a number out front. And just like typically if I have a number and then something next to it, no symbol, that means multiply. So really this means 5 times square root of 32. So now I'm going to look at 32 and think about how does 32 break down in terms of my list of perfect squares. 4 goes into 32, 4 times 8, but now I'm going to kind of think, well, 4 also goes into 8, so there might be something higher. So ideally, we're looking for the highest number. So, I mean, I can't go over 32, so I can really just look at 4, 9, 16, 25. So not only 4 goes into 32, but 16 does. So ideally, I'm looking for that highest one, that highest perfect square that goes into 32, which it would be 16 times 2. Okay, so now square root of 16 is 4. So square root of 16 is 4. Now, since this is 5 times between these, I'm going to have to multiply 5 times 4. And then the square root of 2 stays inside. But now I can do 5 times 4, that is 20. So 20 square root 2. Now let's talk about a second about how I can check this. Now we said we could get an approximation of our answer. So no, this would just be a check. This isn't getting my like exact. And in a minute we'll do some with x's. So if I do a check of what is 5 square root of 32, 5 square root of 32 is approximately 28.28, keeps on going. I can do the same thing with 20 square root 2. 20 square root 2, I'm getting the same thing, 28.28. Let me write that out. Oops. So in both cases, I get 28.28. So now it doesn't tell me if I fully simplified it, but it should be in this case for sure because I can't break down square root of 2. Now, still going off of this example for a second, let's look at that 5 square root of 32. Let's say at first I just broke down 32 to 4 times 8. And then maybe I even like pulled out this 2. 5 times 2 is 10. So I'd still have 10 square root of 8. But then I can think about how 8 is not really fully broken down. 8 is 4 times 2. Square root of 4. Square root of 4 is 2. 10 times 2, 20. Square root of 2. So I can do this multiple ways. I could break it down by smaller numbers, but just know that in the end we need to make sure we have no perfect squares on the inside of the radical. So when I had 10 square root of 8, I wasn't fully simplified yet. Okay, how about some with x's now? How about square root of x cubed? Okay, so with x's, only if I have an even exponent is this going to simplify. So I would break this down to x squared times x to the 1, because x cubed is the same as x squared times x to the 1. Square root of x squared is x, so that comes out, but I have to leave this other square root of x on the inside. So x square root x. Or how about square root of x to the 15th? Okay, again, I need to break this down so it's an even amount of my exponent so it fully simplifies. So if I break this down to x to the 14th times x to the 1, x to the 14th times x to the 1, 14 plus 1 is 15. So that's the same thing, square root of x to the 14th. Let me write this as a rational because it's getting a little bigger. Remember, this is like a 2 here if it's just a square root. 14 divided by 2 is x to the 7th. Okay, so that's when I do 14 divided by 2, it's coming out of the square root. I'm pulling that out of the square root. Now it's just x to the 7th. But this x to the 1 cannot be simplified, so that has to stay inside. So that can't come out. Okay, 2 more. How about this? Let's combine now. Square root of 50x to the 9th. Okay, so let's do some breaking down. So 50 breaks down to 25 times 2. X to the 9th breaks down to, so the next even number below 9 would be 8. So x to the 9th, I'm going to break down to x to the 8th times x. Okay, so now we look at what comes out. Square root of 25 is 5. 2 cannot come out. Square root of x to the 8th, 8 divided by 2, that's going to be x to the 4th. X cannot come out. So the things that came out were the 5 and the x to the 4th. The things that could not come out were the 2 and the x. So that would be my simplified answer. Okay, last one. So this one is going to be a quotient rule. So now I have a square root over square root. So on top, I have square root of 54x to the 11th. And on the bottom, I have square root of 2x to the 6th. So this is a combination of doing the quotient rule and also simplifying. So right now, I think it's probably I could do this a few different ways, but it's probably gonna be easier to first combine these and divide. So 54 divided by 2 is 27. X to the 11th over x to the 6th. Quotient rule here, so 11 minus 6 is 5. Okay, now let's think about how this breaks down. So 27, if I'm trying to think about what perfect square is in 27, 9 times 3, and then break down x to the 5th to an even exponent, x to the 4th x. Kind of like the last one. The 9 comes out, square root of 9 is 3, square root of x to the 4th. That's going to be 4 divided by 2 is x squared. 3 stays inside, x stays inside. So I have 3 and x squared came out. You even like circle them, show them they're out. And I have to leave the 3 and the x on the inside.